Hello everyone and welcome to another video with Mr. Math. Today we're talking about integration techniques, this case in a specific long division. Okay, so we have the integral of x plus 1 divided by x minus 1 dx. We usually will attempt to do long division whenever we have the same degree on the numerator as of the denominator, or perhaps whenever we have a greater degree. On this case, we're going to divide our x plus 1 by x minus 1. Okay, so we take just the first term, x divided by x, and that should be just 1. So 1 times x is x. We put it with a negative sign, negative x. 1 times negative 1 is 1 times negative 1 is negative 1. It's going to pass as positive 1. Okay, then we add these two expressions, x minus x, that will cancel out. That'll be 0. And 1 plus 1 will be 2. So let's remember our algorithm of the division. We know that any polynomial of x is equals to the quotient of x times divisor of x plus remainder of x. Okay, if we divide by our divisor of x, every expression will have that the polynomial of x, which is the expression of the division, is equals to this quotient. These divisors will cancel out and we'll have just the quotient plus this remainder over the d of x, the divisor. So we need to find a way to build this from our division. So changing the words, this here, this x plus 1 here will be our polynomial of x. This 1 here is our quotient of x. This is our divisor of x. And here's our remainder of x. So if we rewrite this according to the algorithm of the division, we'll have something like the integral of the 1 plus the 2, that is still divided by x minus 1 dx. And then we need to start solving from this one. Okay, what can we do here? We could distribute, right? So we'll have the integral of 1 dx plus the integral of 2 over x minus 1 dx. Okay, the integral of 1 dx is just the integral of the x, which will be just x, plus we can pull that coefficient out. That will be 2 integral of 1 over x minus 1 dx. Okay, so how do we solve this part now? We have an 1 over x minus 1. We can apply a u substitution here. So we're going to assume from here that our u is equals to x minus 1, and our du will be just the same dx. Okay, this will be equals, when we replace x plus 2 integral of 1 times dx is the actual dx here, which will be equals to the du. So that'll be du over u, and we know how to integrate that. So this will be x plus 2 natural logarithm of u plus our constant of integration c. Now let's bring back what was the value of u to our expression, and we'll have x plus 2 ln of the absolute value of x minus 1 plus our constant of integration. Okay, and that should be our specific answer for this problem. Right, thank you for watching. I hope this video was helpful for you.